Hello students, welcome back to our YouTube channel. Today we will see one another method to find the relation between beta and gamma function. We are studying about integral transform. Integral transform in which we are studying about beta and gamma function. Correct? As we have seen in previous lecture that beta of mn is equals to gamma of m into gamma of n, gamma of m plus n, where m and n are positive. Correct? We have seen one method to prove this theorem and relation. Now in this lecture we will see one more method to prove this equation, since we know that beta of mn may be written as integration from 0 to infinity x raised to m minus 1 and 1 plus x raised to m plus n dx. We have proved this in previous lecture about the relation of beta function in variable x. Now we can break this integral into two parts, such as integration from 0 to 1 x raised to m minus 1, 1 plus x raised to m plus n dx, plus integration from 1 to infinity x raised to m minus 1 dx upon 1 plus x raised to m plus n. Since we know that integration of a to b f dx is equals to integration a to c dx plus c to b f dx, where a is less than c less than b. We know already this result in lower class of mathematics. Now we have integration from 0 to 1 x raised to n minus 1 upon 1 plus x m plus n dx, plus integration from 1 to infinity x raised to m minus 1 dx upon 1 plus x raised to m plus 1. This is our part A and this is our part B. Let us work on part B to simplify this equation. So, since b is equals to integration from 1 to infinity x raised to m minus 1, 1 plus x raised to m plus n dx. Now, to get this relation, put 1 plus x is equals to y. Correct? We want dx, therefore we will get minus dx upon x square equal to dy. Correct? And when x is running from 1 to infinity, when x is equals to 1, then y is equals to 1. And when x is equals to infinity, then 1 upon infinity becomes 0, then y is equals to 0. So we have the limit as integration from 1 to 0, x raised to m minus 1 is equals to m minus 1 is equals to 1 upon y raised to m minus 1. Then 1 plus 1 upon y raised to m plus n, and dx is equals to dy upon dy minus dy minus x square. Dx is equals to minus x square dy. Correct? Or we can write it as minus, just a moment, dy is equals to x square, and 1 upon x square is it becomes here 1 upon y square minus y square. Correct? Since 1 upon x is equals to y, so 1 upon x square becomes y square, and we are getting x square here. We can write it as 1 upon y square. Now, since we have minus sign and integration running from 1 to 0, we can write it as 0 to 1, 1 upon y raised to m minus 1, y plus 1 raised to m plus n by y raised to m plus n, and dy upon y square. Right? Now we can write this equation as 0 to 1. This y plus m we can shift into numerator, and this y raised to m minus 1 and 1 plus y raised to m plus n dy by y square. Correct? Yes. Now we can find we can say this integration from 0 to 1 plus y m plus n plus 2 y m plus n into y 1 minus m into y raised to minus 2 dy. We have shift all y into numerator and 1 plus y into denominator. We will get integration from 0 to 1 y raised to m plus n plus 1 minus m minus 2. So plus m minus m will cancel, and n plus 1 minus 2 dy. We will get integration from 0 to 1 y raised to n minus 1 1 plus y m plus n dy. This is our part B, and we have part A plus part B. Correct? So we can write A plus B as integration from 0 to 1 x raised to m minus 1 1 plus x raised to m plus 1 m plus n dx, and this part B becomes integration from 0 to 1 y raised to n minus 1 1 plus y Now replace all x or all y by x. We will get integration from 0 to 1 x raised to n minus 1 plus x raised to n minus 1 1 plus x raised to n plus n dx, and which is equals to gamma of m into gamma of n divided by gamma m plus n, which is equal to gamma of n by gamma of n, gamma of n plus n. It is our required result. Now we can try to find, we are going to find gamma of half is equals to root pi. Gamma of half is equals to root pi. Correct? To find this, we are going to use the relation beta and n, which is equals to gamma of m into gamma of n, gamma of m plus n. If we take m equal to n equal to half, we will get half into half is equal to gamma half into gamma half, gamma of 1 half plus half. We get gamma of 1 by 2, gamma of 1 by 2 into gamma of 1, and gamma of 1 is equals to 1. So we will get gamma of 1 by 2 square equals to beta 1 by 2, 1 by 2. Now, using the definition of beta function, we will see, since we have beta mn is equals to integration from 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 dx. So beta of half becomes integration from 0 to 1 x raised to half minus 1 and 1 minus x raised to half minus 1 dx, and which is equals to integration from 0 to 1 x raised to minus 1 by 2 and 1 minus x raised to minus 1 by 2 dx. Correct? Now put x is equals to sine square theta. Put x is equals to sine square theta. Therefore, we will get dx is equals to 2 sine theta cos theta d theta, as x is equals to 0, sine 0 becomes, then theta becomes 0, and as x is equals to 1, then theta becomes pi by 2. So limit are change to 0 to pi by 2. Correct? And we know that integration from 0 to pi by 2 x is equal to sine square theta raised to minus 1 by 2, then 1 minus sine square theta raised to minus 1 by 2, and dx is equal to 2 sine theta cos theta d theta. Correct? Now, after that, we will try to simplify this equation. We get integration from 0 to pi by 2. This 2 and 2 get cancelled. We get 1 upon sine theta, and it will give us cos square theta. Square get cancelled. We will get 1 upon cos theta into 2 sine theta d cos theta d theta. Correct? Sine theta get cancelled, cos theta get cancelled. Integration from 0 to pi by 2 will give us 2 into d theta. And theta will give us theta 0 to pi by 2. And we have 2 into pi by 2 minus 0, which is equal to pi. And we have beta 1 by 2 comma 1 by 2 is equal to pi, since beta 1 by 2 comma 1 by 2 is equal to gamma of 2 square, which is equal to pi, will give us gamma, like that, gamma of 2 is equal to root pi, and hence the result we have done the result. So always remember gamma of 2 is always root pi. In next lecture, now we have completed our theory part of beta and gamma function. We have completed the all properties and theorems of beta and gamma function, all the forms and different phases of beta and gamma function in previous lecture. You can watch that videos and try to learn each and every form of beta and gamma function, because we many times come across a function which has a phase of beta or gamma function, and we got confused how to solve that, while we can use only beta and gamma function at that place and try easily solve that example. So always try to remember all the phases of beta and gamma function to get easily result in your applied physics or mathematical physics. Now we will stop here and try to do some examples on beta and gamma function in next lecture. Till then, thank you. Bye.